Welcome back to Off the Down Low. We got these, this is going to be episode, or part two, I should say, of these strange things that are captured on the International Space Station live feed. I'm going to go ahead and write part two on this. And just let this thing go here, because it's amazing that I'm going to change this to ISS, and hopefully we get some. I have not seen this feed yet. This is going to be a multi-part, because whenever I find these, I'm going to go ahead and put them up. What should I call these things? What do we want to call these things? Because they are very strange, and they are very, very beautiful at times. Here comes one now. Would you look at that? Right on time. Look at that. Get this filter here to maybe be able to bring some of these things out. Let's see, we apply the LUT. And let's put this color correction on here and bring the gamma up a little bit. Maybe not the gamma, but the contrast. Let's try that. And maybe the brightness. Let's see what we can do to bring these things out. Wow, look at that. Here we go. This is what I'm talking about. This is what I wanted to see. And what I've been looking for and what I've been looking out for. Is this kind of, let's get saturation going on. Okay, there we go. Now we're bringing out some of this. Let's get this. Look at that. Do you see? I'm going to take this LUT off because it's taking some. I'm going to put no filters on this. No LUT. No color correction. Okay, just the way it is. There we go. That's the way to do it. Okay, so what are these? Are these islands? If this is an island, what part of the world is it in? Could this be California here? Could this be Alaska? Could this be Papua New Guinea? Are there towns that have these shapes? That have these shapes here? And then also look like they're on fire over here. And what shape is this? What part of the world is that? Could it be Africa? Could this be Cairo and the Nile? Could this be and now if we're thinking about we can't see the whole continent. If it was Africa, we would be too close to the surface of the earth for that to happen. So these are 250 miles away. So if we were going to do the math, I would have to have some type of formula, and I could probably do this with some astrophysical formula with distance. And I believe that formula is, let me get this out of the way here. I believe that formula is D equals, no, we don't want distance. We know the distance. So I'm going to work on that, and I'm going to work on an equation or a formula that will tell us roughly how big these things can be. You remember, here's the arm of there's the arm of the International Space Station right here in this right upper hand corner. So they're going to look like they're appearing out of nowhere. But look at these things in a row. What in the world is this? Now, I had some thoughts, and I'm going to take me out of this so that you don't have to worry about it. But I have to put my speculations banner up there, okay? Because I just want to do that because it's safe. It's just good measure for me because I don't want to, – Anyways, the Is this the right size for the... Oh, there we go. Let me see if we can get this smaller so we could see this better on this. Make a frame there. There we go. That's better. What I'm going to say is a theory that I have, and it's going to go right along with the so-called Nemesis brown dwarf sun's twin, binary sun's twin, Nemesis, the brown dwarf twin of the sun that has not ignited to a full-on star, and it is a brown dwarf, smaller than the sun, has a great gravitational pull, a very strong gravitational pull. And with this, it brings in its own, because it is a brown dwarf star, it still is a star, it brings with it gravitational fields. Not only that, by itself has a gravitational field, has a magnetic influence. It also has electromagnetic storms and a electromagnetic field and a magnosphere, just like any other star would. Now, follow me here. Stick with me. I don't want to talk over anybody's head. I'm going to try to say this in layman terms. A solar system is just like our solar system. We have a star, the sun. We have planets around us. Mercury, Venus, Earth, Mars, Jupiter, and so on. Now, that's a solar system. We follow the sun around, and the sun is following, is inside of it's got its own trajectory, and we go around it like a spiral following it. It's pulling us with its gravitational or magnetic pull that we are attracted to, and we are magnetically bound to it. The moon is tidally bound to our planet because it's the nearest, most gravitation that it can bind to. Okay, because it's in this gravitational pull. Okay, so one celestial object that's bigger than another celestial object, when they become close, one is attracted to the other, dependent upon the actual makeup of the celestial object, and whether it be a planet or a moon or what it's made out of and its elemental, down to its chemical. Oh, look at this. Let me stop what I'm saying and look at this. Beautiful hair. Beautiful, whatever that is, just flying through space like it's nothing. I showed these images and videos and my wife was looking at them, and she says, I said, could they be cities on the surface of the earth? And she says, no, they look like they're out there floating in space. And they do look like they're out there floating in space. What is this? This is amazing. Wow. This is unbelievable and extraordinary. And that is not a city. What in the world are we looking at? Now, let me give you my speculation. Look at that. That is just amazing. Amazing. You have to rewind that to check that out there. Now, my speculation is, because there is a so-called binary brown dwarf twin of the Earth. Let me just pause this for a second, and I'm going to try to make this fit. Because the twin, the sun has a brown dwarf, and because it is part of our solar system, and because it is bound to and gravitationally, gravitationally bound to the sun, and they go around and orbit around each other. And that's what they do. Okay. and they go round and round till something else will influence it. Let me try to fit this in there so we get everything. Until something else influences it. And that's part of the, forgive me for this, there we go, I should have did this before, but I'm so excited. Until something else influences it or perturbs it, it will then stop its orbital trajectory or orbital dynamics that it is following. The orbital velocity, everything cannot be changed until something perturbs or comes in and has an effect on it to where it will change directions. An object will keep on moving in its direction and in its integrity and all of that. I think it's Newton's law, right? Or Kepler's, I can't remember. It will keep on going until something else stops it or influences it. Okay, so in space, there are things flying around. Now, because there is a whole other brown dwarf, follow me here. I'm sorry it takes me so long to explain this, but I'll make it to it. It's because there is a brown dwarf that we know that we call Planet X, but I don't, whoa, that was really cool lightning. That is a storm, okay? So let's rewind this, and sorry that I got distracted. So we have these things floating through the sky or floating through space. Now let's watch and see if we can see this. The lightning is more towards, the lightning should be right above the earth. Let's slow this down and let's see if we can see any of these flying objects in front of the lightning of the storm. And I don't see any. That would have been a really good that'll be indicative of it being under or over. Would have told of where exactly these golden dragons, whoa, if you will, where these golden whoa, look at that. Let's keep this lightning going. This is awesome. Did not expect this. Here comes the sun. Here comes the sun. And there we go. Look how fast the sun and its photons will cover up this whatever it is, and we don't see any more of these stars in the background. And now oh shoot, I screwed that up. I should have left that alone because that was really cool. It was a really slow moving lightning there coming to fruition. So let me finish this while this thing tries to load itself up again. There we go. Let's rewind it a little bit there. So when we have something like a brown dwarf that comes in, and a brown dwarf is very dense, and it will have a large gravitational pull because it is pretty much a star. It is a star. It's a brown dwarf star. It is a star. It's just not ignited as a sun, and it starts and then starts to burn. Not burn, but it starts to make helium right off the bat. Burns hydrogen, then makes it into helium, and then so on and so forth. Since, this is beautiful, isn't it? Since this brown dwarf is not ignited, it is heavy, and it is iron, abundant with iron. Okay, it's abundant with a lot of the heavier metals on the periodic table. What do we have here? This is interesting. This could be one of those things, but it's a little bit, it's illuminated. Is that one of them? Okay, wait, we may, that's one of them there with partial illumination from the sun. What is that? Is that something floating in space, or is that on the surface of the earth? That is exactly, I believe, what we are looking at. So that is a great shot there. And it's still not beyond a shadow of a doubt that it is on the Earth's surface or above it. It still looks like it's above it. Here we have some more. And these are the ones that I really, really wanted to see, was when the terminator of the Earth's night and day was coming, and to see if we can see a little more into what these things are. And I cannot tell. Are those clouds? Is it mist in space? What are these things? Now, let me finish while we're watching these. Let me finish my assessment or interpretation of this brown dwarf and its own planets and its own planets' moons, and it's coming into our proximity of our sun, and it's smaller than our sun. But it may be more dense and more magnetic and more gravitationally, more of an influence gravitationally, with the gravitation to all of our celestial objects that are in our solar system. It could actually, and theoretically, you can steal one object from another solar system if you have a big enough pull of gravity. Okay, we just lost the feed here, so let me just fast forward here anywhere randomly. So because we have this thing coming into our proximity, it's going to have an influence on our sun, and we're going to have an influence on it. It's going to have an influence on every one of our celestial objects, every one of our planets, every one of our most gravitational, our planet with the most the pull gravitationally is Jupiter, because it's so big, and Jupiter just stops all of our free-flying asteroids, comets, whatever it is. It will suck it right in, and it's kind of like a big giant punching bag where stuff will go, and it'll die in Jupiter, and when it goes in Jupiter, it's not going to come out because it'll just stay bound to it. Jupiter is so gravitational. There's so much gravity on Jupiter, and it pulls so hard that it kept all of the gases that were left over from the creation of the solar system, which are little tiny particles of mist that they can't even escape its gravity. Jupiter is pretty much not a solid planet. There's a small solid core, they believe, but most of it, the lion's share of it, is not. If you had a parachute and you jumped into the atmosphere of Jupiter, you wouldn't need a parachute, actually, because at one point in time you will float down. It's so dense, and at one point in time it will be just like the Earth's temperature, but you will end up getting spaghettified or smashed or whatever with all of the gravitation. But at one point in some layer of the Jupiter's atmosphere, there is a comfortable place if you can find out how to stay there in that area, but you wouldn't be able to breathe. And I digress. So this brown dwarf is coming into our proximity of our solar system, where they're both affecting one another. So what happens with this when it happens is, just like you have two arcing currents when they get close to one another, and the static electricity and the electromagnetic fields and electromagnetic interference will interfere with one another, and they will arc, sometimes meet. And just like when you try to turn in the olden days, if you didn't have ground, the houses were grounded differently. So you can go turn on the light, and if you had wet shoes or the carpet was wet, you would get a little shock from the light switch. That is pretty much completing the circuit there. So when these arcs come and these electromagnetic storms that we were just looking at, which we just witnessed, can sometimes affect one another. Now, if it's in our atmosphere, that's one thing. If it's above, and well, it's right along the troposphere. The troposphere is where all the weather happens, which I believe is pretty much way up there. And it could theoretically have a electromagnetic pulse, or not a pulse, but electromagnetic, a lightning or static, or just a influence of electromagnetic energy that could come out of our atmosphere, just like we have a magnetosphere that protects us from the solar wind here on Earth, which makes the northern lights, which is the sun's coronal mass ejection or sun solar wind. What if we had, or they were close enough, the brown dwarf and the sun, and they had somewhat of an arc that happened, and electromagnetic energy somehow was sucked into, we sucked some of the brown dwarf, they sucked some of our electromagnetic, there was an arc, and then we have all these weird, anomalous lightning, but really they're arcing or they're affecting one another. And we're having a lot of volcanoes going off, because what happens when there's another influence of gravity in the area that's never been here before, maybe never, but has been before, that comes into proximity and close enough to affect the Earth's tectonic plates and will pull upon them, lifting them up, just like the high tide will pull the water up and will follow the moon around. Just right behind it, it follows the moon around because it wants to, it's a little bit lighter and it's pulling towards the moon. That's why we have high tides and low tides. Now, if this thing is affecting it, and it is having these electromagnetic storms that are meeting, and it's so close that these things can travel through the vacuum of space, and these particles of high energy particles are meeting and connecting and arcing, so to speak, if you will. There is a chemical binding, chemical, it would bind by the, and use whatever high energy particles of the sun are coming out. There's going to be some metals in there. And it's going to have some iron in it, because the sun and this brown dwarf, which is highly abundant with the iron, it's going to have what's called iron oxide. Now, these are all just chemical bonds. Chemical bonds. Just on the periodic, just like on the periodic table of elements, the heavier the element, the heavier the star, and it will burn going up going up each element, will keep burning each element until it gets up to iron, and then after iron it'll go up to carbon, and then all the heavy metals, and then it'll implode upon itself, and then it will have a supernova, because it's all the metals and the friction and the weight of them is what makes a star explode, because all these elements are trying to bind together and they can't stand the heat, and they will implode, not explode. A supernova is not an explosion, it's an implosion upon itself. Sometimes the stars are so big after they burn out all of their fueled chemical bonds, and they get to that heaviest iron, and they keep on going, and then they are so heavy that they implode upon themselves. And if you have a big giant star, depending upon what cosmic dust is in the air, if in the area, you'll have heated when you ever heard of the term ionized? That's when you take a element and you bring it up to the part of its own chemical reaction of burning or becoming another state, like the vitrification of rock or the melting of silica to make sand. To make glass, sand to glass. There is and then there's plasma, the fourth state of matter, where if something gets hot enough, whatever element, it will what's called go ionized. And ionized is when something will be like plasma. That's the ionization, and it will heat up so hot that it'll have this point of which it will turn into plasma, if you will, for simplifying it. Is it getting dark again here? So what I'm thinking is these things that are floating in space, they are, now the brown dwarf is going to be like the embers of a campfire, where it's going to be red and hot. It's still going to be hot. It's going to give out heat, but it's not ignited where it's burning. And the brown dwarf is right down there with a hot iron it's just like when you heat up the iron, like the blacksmiths, and it's red. That's what this brown dwarf is. It's a big iron ball. And with this and this really solid, dense, and really, really powerful magnetic field will come in, perturb things, disturb things. And now what I'm thinking is there are charged particles in space that are from these two interacting stars, a brown dwarf and our sun, and these charged particles are racing and rushing out to meet one another in an arc, or a meeting of the high energy particles, which are magnetically attracted to one another, and we're so close that this thing is actually doing it, and these charged particles are meeting, and they're ionizing the iron particles in space. Space is a vacuum. These charged particles are meeting and colliding, creating ionized or iron oxide and ionized iron that glows like plasma. Plasma, iron in the plasma state, or iron in its state of which it glows. And because it's not being affected by anything else in its trajectory, it stops right where it meets. This high energy particles stop right where they meet, and these are where the arced or high energy particles of like lightning come towards one another, and they have parts of the chemical element of the heavy metals, and they meet and they're burning, they're ionized, they're glowing, just like the star factory in the constellation of Orion. Down below it, you have Orion's Nebula, where there are stars that are produced, something like 5 or 6 per year, I believe. I may be mistaken, but from what I remember, that's our star factory in our galaxy here in the Milky Way that we can observe, and it glows. It has like a cloud that surrounds it. It looks like a cloud, but what it is actually ionized particles of different elements that turn different colors. It looks white from here, but it's just white hot because these 4 stars are so close together that they ionize the particles in the vacuum of space around them, and they just glow. The particles of the misty glow because it's so hot that they just ionize where they are. Now I'm going to put this up here, and then I'm going to end this video because it's kind of long. And maybe let it go a little longer if we get any more of these. But now think of this. Now that we have possibly these ionized particles in space, and they're not moving because they hit each other, they collided, and now they stopped one another's trajectory, and they're just floating through space where they met. This is just a speculation in my thoughts and theories. Maybe that's what we're looking at. We're looking at, now if there's another whole solar system that goes around a brown dwarf, and then we have our own solar system, maybe we go around the sun, there's going to be a lot of different way off trajectories. We don't go around shaped. Our pancake shaped solar system is not really pancake shaped. It's more like a corkscrew or a DNA strand where it's twisted. If we have planets like that that are following the sun like we are, and then following this brown dwarf, there's going to be a lot of perpendicular, hyper angled trajectories and orbital, the orbit of these things are going to be all over the place. And one thing's going to be coming this way, one thing's going to be going that way, and they're going to be disturbing this one, perturbing this one's orbit, and all these things that are going to change because now they're being affected by one another, and it's called perturbing, where my orbital velocity is now perturbed, which means I'm turning a little bit to the left because now there's a big object there that I'm going towards because it's bigger than me, and I'm gravitationally bound a little bit. Then it goes away, but I now have a different orbital trajectory. And that's why things change. That's why we have comets. Comets are from the beginning of the solar system's creation, and it's where everything was really wild and all this chaotic movement and spinning and everything, and this ice and everything was spun off of the hotter terrestrial planets that form towards the sun, or the star that ignites, and then you get it cooler as you go out. And then all of that really high velocity planetary, the theory of planetary, the burgeoning of planets in the accretion disk and the igniting of a star, you'll have the colder, it'll get cooler as it gets away from the center where the star has just been formed. And it's called a ice line, I believe. It's called I believe that's what they call it, where it's colder and everything will be icy after that. And that's where there's a lot of spinning, because the accretion disk is where all the dust and all of the elements are, and that's where everything is really violently coming together, and it's forming planets and moons, and it gets right out towards the ice line, and then that's where the comets are actually bound together and spun off of and thrown into some trajectory, and then they come back because they're gravitationally bound to something in that solar system. And that's where they have some weird, really high ecliptical, way out there, and they come back in really, really fast, like Halley's Comet that comes back every 80 something years because it's been thrown out, but then it comes back like a slingshot. So what I'm saying is these things could be pretty much randomly, this dynamic or dynamics that this solar star system is coming in, and it's not as big as ours, but it's just as formidable, because it will have an effect on us, because none of these objects have ever been in our proximity and have a gravitational field, and the brown dwarf star has a huge gravitational field because it is iron, and it's basically stopped at iron, and it's going to stay that way, and it's still hot, I believe, if I'm not correct, and because it's been a while since I've been in my planetary and my astrophysics classes that I took. So this is what I'm thinking with my limited amount of, I don't have a degree, but I did take some classes on planetary science, some chemistry, astrophysics based classes, and I took them everywhere from Harvard to Stanford, and also Arizona State University. And what was the other one? No, not Stanford. Harvard. Anyways, there's some semblance of these things that are still in my mind, and I learned a lot. That this could be ionized chemical elements that are floating out in space because there is another star close or inside of our solar system. That is my theory. That is my speculation. And this could be ionized particles, charged particles that are floating through, that could be caused by lightning, that could cause its own lightning, an electromagnetic interference, like when you touch something and you feel a shock with your clothes or whatever, that kind of thing. Okay? You have no control over it. It grounds and boom, it releases that like a capacitance. These things are huge, planetary celestial objects. These things are the most powerful things. They're astronomically sized, powerful, cataclysmic holding power these things have. I wouldn't how do you say, vote it out to be that is the truth. So this is going to be part 2. This is at, we're at 34 minutes, and I think we got a lot of good shots here, and I'm going to remember this one. I'm going to put the part 2 up here probably tomorrow, and I'm going to put the link here for this ISS HD Earth viewing experiment that's giving us all of this really nice celestial events that are happening up here that we are able to see and wonder, and this ISS is capturing it all. I would love to see how it looks with the naked eye as an astronaut is in space on the ISS, what these objects are and what they look like with the naked eye. I bet you they're unbelievably beautiful. This is something that human eyes probably rarely have seen, if at all. And I don't know if we have any type of names for this, or if there was any prior civilization that would even know of these existence. And can we see these from the Earth? Very, very, very intriguing. And anyways, we're at 35 minutes. This is a pretty long video. And I was rambling there, but hey, I'm going to make another one of these, and I hope you guys enjoyed this. Please do me a favor and smash that like and subscribe if you like what I'm doing. And you want to hear more and I don't ramble too much, I don't write my own scripts. I just kind of go on a whim. You probably know that by just listening to me. The more I do it, the better I'll get and the more concise I'll get. And I hope that is something that I can achieve and that I can feel as though I have some support with you guys. And so far, so good. Loving the comments. Any suggestions, any type of critique, please send it my way. I like any and all comments. And I think this will do it. Thanks for watching again. And I'll see you soon. And signing off. Till next time. Peace. Got to turn the light on.